Hey, this is Dr. B, and let's check out the Mars Ingenuity helicopter. It deploys from the bottom of the Perseverance rover. It's twin-rotored because there's very little atmosphere on Mars. It goes for a whopping 90 seconds. That's a closer look at the Perseverance rover. And it flies autonomously since Mars is 4 light minutes away. You can't control it with a joystick. It's designed to do two things. One, during its 90-second flight, it can take all sorts of pictures as it covers a lot more distance than the rover can. And number two, it's a proof of concept. It's the first time we've ever had a helicopter on another planet, period. So there it is. It's landing, and it'll be really something to see. You can film it from the rover. It'll take video and pictures itself, and that's a little look at the rover. Now, I want to show you a couple of other things, including some basic information. Let's go to this image here. Okay, let me make sure I get some basic information to help you answer your questions. It's left on July 30th from Florida. It's arriving on the 18th of February, and there it is shown arriving there. That's 7 months later. Notice that by that time the Earth has traveled more than halfway its distance around the Sun, that it does so annually. It's going to cover 56 million miles to get from there to there. And I do have a question for anybody that can tackle it. That's long distance, right? See that distance from there to there? Why not go that way? Why not simply wait until Mars is, say, about there, take off, meet it there, curve your way in, I suppose, so that you can not smash into it, but land? Clearly, there's something wrong with that concept, but maybe somebody can tell me what that is. Okay, it's heading for the Jezero crater. Its goal is to look for ancient signs of life. The Jezero crater shows signs of a water inlet, signs of a huge pool, a lake if you will, and signs of a water outlet. There's signs of a river delta. So they're confident that water was there a long time ago, and it seems like a great place to look for signs of ancient, or who knows, maybe present life. So that's their main goal. Let me show you one last thing. It's about the rover itself. Before I go out, let me show you this right here. I'll show you the whole thing, but as long as I have it focused there. That's the pixel camera, and that's the main thing on board that chemists are really interested in. There's a lot here that chemists are interested in. This thing right here takes core samples, for example, and then it can bottle them up in this metal container and drop them off and just leave them on the ground, basically. I don't think anybody's going to take them. And they're waiting for the next mission to come over, and then they can take them with them. So that's interesting. The pixel camera is both visible and X-ray. It is capable of dramatic close-ups, which will be useful for macroscopically looking for signs of biological life. And it also has an X-ray diffraction camera, which can give you huge amounts of information about the chemical makeup of whatever it's looking at. So that's the pixel camera. This site's cool because you can poke around, you can move this thing like this and like this, which is fun. And if I can circle around to the back here, that is the radioisotope thermoelectric generator right there. That is essentially has a large chunk of plutonium oxide, 238 I believe inside. It's radioactive, it's naturally very hot, so all you have to do is convert that heat into electricity and you've got yourself essentially an 80-year battery. So that's been NASA's power source for a long time. They do rely on that heavily. Okay, that's a little bit about the Mars Ingenuity helicopter, the Perseverance rover, and the mission itself. And they'll be landing in February of 2021.